Have you ever opened your pantry and just marveled at how your food stays fresh for, weeks, even months? Well, it's not by accident. Today, we're peeling back the layers on the invisible science that makes all of that possible.
Think about it. It's definitely not magic that keeps your chips with that perfect crunch or your coffee smelling amazing. It's actually a precisely engineered battle, and it's happening inside every single package. So what exactly are we fighting against?
Well, every sealed package is really a tiny fortress. It's designed specifically to keep two invisible enemies from getting in and just ruining your food.
All right, here are our two main culprits. First up, you've got oxygen. This is the great destroyer of flavor. It's what makes oils go rancid and snacks go stale. And then its partner in crime, moisture. This is the enemy of texture. It's what turns anything crispy into a soggy, sad mess. The whole point of modern food packaging is to keep these two out.
Okay, so if oxygen and moisture are the villains of our story, then who are the heroes? Let's meet the champions in this fight. We're talking about specialized barrier materials, and each one has its own unique superpower.
So the core concept we need to understand is a material's barrier property. You can think of it like a high-tech, invisible shield that blocks these invaders. Now, we measure its strength by what's called its transmission rate, or TR, and when it comes to keeping food fresh, a lower TR number is always, always better.
And when we actually measure how well different materials can block oxygen, wow, the differences are just staggering. I mean, look at a standard plastic like polyethylene or PE. Its number is through the roof, which means it offers very, very little protection. But then you look at something like EVOH. Its transmission rate is almost zero. It is an absolutely elite oxygen blocker, a true superhero in this fight.
But here's the twist. That same PE plastic that was so bad against oxygen, it turns out it's an absolute champion at blocking moisture. And our oxygen-blocking superhero, EVOH, well, it's actually pretty weak when it comes to stopping water vapor. And this right here reveals a critical rule in packaging. There is no single perfect material. It's all about picking the right hero for the right fight. And speaking of EVOH, it has a pretty big secret weakness. You could call it the material's kryptonite. See, all of its amazing oxygen-blocking power just tanks when it gets humid. And this is a huge deal for engineers. They literally have to protect the protector, usually by sandwiching that EVOH layer between other plastics that can keep it nice and dry. But you can't just pick a material off a chart and call it a day. Not even close. The finished package has to be rigorously, and I mean rigorously tested, to prove that it's not only effective, but most importantly, that it's completely safe for you. And this process is incredibly thorough. First, they do standardized tests to measure the material's raw barrier performance. Then, engineers use what are called food simulants. These are special liquids that mimic all kinds of foods, like acidic or fatty ones. And they do that to see if any chemicals from the plastic might migrate out. And finally, they have to confirm that any potential migration is way, way below strict global safety limits. And this really gets to a crucial point. Something that experts in the field are always saying. A materials data sheet, that number on the chart, does not equal your food's actual shelf life. The real world is just so much more complicated. Because in reality, there is a whole system of factors at play. Think about it. A single microscopic leak in the seal of the package can completely defeat the most advanced high-tech barrier film. The amount of air left in the bag, how the food itself ages, even tiny little cracks that happen during shipping. All of these can have a way bigger impact than the plastic's official rate. But of course, today, there's another massive factor in this whole equation. The quest for the highest performance packaging is now colliding head-on with the urgent global need for sustainability. And this table just lays out the core dilemma perfectly. You see, the materials with the highest barrier power, like those old-school PVDC-coated films, are often the most difficult ones to recycle. But then, the materials that recyclers love, simple monomaterials, well, they tend to have the weakest barrier properties. It's a direct trade-off, performance versus the planet. So the grand challenge for today's packaging designers is to basically innovate their way out of this corner.
They're trying to find brand new combinations, things like clear coatings or using incredibly thin layers of high-performance plastics to create packaging that can do both jobs, protect the food and protect the planet.
And this brings us to what might be the most important takeaway of all. Keeping our food fresh isn't just about picking the right plastic film. It is about designing a complete, high-functioning system. And this isn't just some voluntary goal, some nice-to-have idea. Major regulations are setting hard deadlines around this date, mandating that all packaging has to be designed for recycling. The clock is absolutely ticking, and it's pushing innovation faster than ever before. So here's what it all comes down to. The best packaging, the stuff that really works, is a system in perfect harmony. The film, the seal, the atmosphere inside, and even its ability to be recycled. It all has to work together to deliver fresh, safe food. So the next time you open a bag of coffee or a package of fresh salad, just take a closer look. Notice that thin, clear film. Feel the strength of the seal as you pull it apart. Hear that little puff of air? Now you know. You can see the invisible science that went into every single one of those decisions, all to deliver that one perfect moment of freshness.